Why a $5 plastic valve is a $2,000 engine oil leak. The silenced PCV. You walk into your garage or look at your driveway on a beautiful Saturday morning. A beautiful morning, that is, until you see it. A dark, ominous puddle of oil pooling directly under the center of your car's engine bay. You feel that cold pit of dread in your stomach. You immediately drive to a local mechanic. After 30 minutes on the lift, the technician hands you an estimate that feels like a physical punch. It's the rear main seal, he says. The part is only $50, but the labor is $1,800. We have to drop the entire transmission to get to it. You are facing a $2,000 mechanical catastrophe. You panic, your weekend is ruined, and you curse your bad luck. But here is the engineering reality that 99% of drivers do not know. Catastrophic seal failures rarely happen without a cause. Very often, that $2,000 oil leak is not caused by a bad seal. It is caused by a tiny, hidden, $5 piece of plastic that you have likely ignored since the day you bought the car. The PCV valve. If you want to know how this single, neglected plastic component creates an unstoppable pressure bomb that explodes your engine's seals, keep watching. To understand the immense power of internal engine pressure, we first have to deconstruct what is actually happening inside the cylinder during the combustion process. Most people think that the seal between the piston rings and the cylinder wall is 100% perfect. This is a scientific illusion. Engineering is rarely about perfection. It is about managing imperfections. Every single time your engine fires a spark and ignites the fuel-air mixture, an immense explosion occurs. This explosion generates staggering pressures, often exceeding 1,000 pounds per square inch. The piston rings are designed to contain this pressure and force the piston down, converting that energy into rotational motion. However, even in a brand new, flawlessly engineered engine, a small amount of this high-pressure combustion gas, the fuel-air mixture combined with burn exhaust, inevitably squeezes past the piston rings. This phenomenon is known as blow-by gas. This blow-by gas is not just air. It is a dangerous, chemical nightmare. It is a mixture of hot, carbon-loaded soot, unburned fuel, and water vapor. And where does all of this hot, pressurized gas go when it leaks past the pistons? It doesn't go out the exhaust pipe. It goes directly down into the crankcase, the main body of the engine where the crankshaft, connecting rods, and the oil supply are housed. This is the central engineering problem that every engine must solve. If this blow-by gas is allowed to accumulate, the results are devastating. First, it physically pressurizes the crankcase. Imagine blowing air into a sealed aluminum box thousands of times a minute. The pressure inside rises rapidly. Secondly, the chemical contaminants in the blow-by gas mix with your engine oil. The water vapor and soot form a thick, poisonous, black acid sludge. While poor maintenance is the ultimate culprit, ignoring the PCV system is a guaranteed recipe for internal engine sludge and eventual catastrophic engine death. This is the singular, critical reason why the Positive Crankcase Ventilation System, or PCV, exists. In the early days of automotive engineering, engines simply had a road draft tube. This was literally just a piece of metal tubing that pointed to the ground, allowing internal pressure to passively vent into the atmosphere. It was simple, but it was incredibly polluting and only worked efficiently at higher speeds. Then, engineers developed the PCV system, which became mandatory in the 1960s. The PCV valve is not just a tube, it is a precisely calibrated one-way check valve. Its primary job is to create a sealed environment that draws the blow-by gases out of the crankcase and reroutes them back into the engine's intake manifold, where they are mixed with fresh air and fuel and burned again during the next combustion cycle. It turns a dangerous contaminant into a burnable fuel source. But how does it work, and how does this simple logic fail so catastrophically? The system relies completely on physics. Specifically, it relies on the engine's intake manifold vacuum. When you start your engine and are idling or cruising gently, the engine's intake is creating a massive vacuum. It is physically sucking air. The PCV system connects this high vacuum area to the pressurized crankcase. The PCV valve is calibrated to allow the vacuum to overpower the crankcase pressure. At idle, when the vacuum is highest, the valve opens just a tiny amount, allowing only a specific, measured volume of gas to escape. When you slam on the throttle, the vacuum drops, the crankcase pressure spikes, and the valve opens wide to accommodate the massive surge of blow-by gas. It is a dynamic, constant balancing act. But, as we learned in our timing chain video, the absolute enemy of all mechanical systems is dirty oil and heat. And the PCV valve is at the exact point where dirty engine oil meets intense heat. The hot, carbon-loaded blow-by gases carry tiny microscopic droplets of engine oil and water vapor directly into the PCV valve. Over tens of thousands of miles, especially if you have ignored proper oil change intervals, this oily, acidic sludge begins to build up inside the tiny plastic valve mechanism. The carbon hardens, acting like mechanical cement. Eventually, one of two terrifying mechanical fates occurs. Scenario 1 is that the valve sticks open. This is actually the better scenario. If the PCV valve sticks open, the intake manifold vacuum is constantly sucking from the crankcase. The vacuum pulls massive, unmeasured amounts of unmetered blow-by gas and oil vapor into the engine. The computer becomes confused, thinking there is a massive vacuum leak. The car idles violently, stalls, misfires, and begins to consume staggering amounts of engine oil, sometimes a quart every 500 miles. You get a check engine light, you replace a few sensors, and eventually, a competent mechanic replaces the $5 PCV valve, and the problem is solved. However, Scenario 2 is the financial nightmare that mechanics never warn you about. And it is the most common failure mode. The sludge and carbon do not make the valve stick open. They completely, totally, irreversibly clog the valve shut. The PCV valve, the only official ventilation point for the entire engine, becomes a solid plastic cork. Now, the engine has zero ventilation. But you are still driving. The pistons are still exploding fuel thousands of times a minute. The blow-by gases are still squeezing past the rings, loading the crankcase with pressurized chemical soot. Now, that high combustion pressure has nowhere to go. The crankcase turns into a high-pressure ticking time bomb. As the internal pressure rises past dangerous engineering thresholds, it creates an immense mechanical force. And that force does not stop. The pressurized gas and the now acidic oil seek the path of least resistance. They are not powerful enough to explode through the thick cast iron or aluminum engine block itself. Instead, they are directed to the weakest points in the engine structure: the seals and gaskets. The pressure first attacks your simple gaskets: the valve cover gasket, the oil pan gasket. They begin to bleed and weep oil, making a mess. But the pressure isn't satisfied. It seeks the largest, weakest, and most critical seal: the rear main seal. The rear main seal is a large, circular piece of rubber that surrounds the output end of the crankshaft, stopping the engine oil from spraying out where the engine connects to the transmission. It is the ultimate dam holding back the engine's entire oil supply. The high, unchecked crankcase pressure from the clogged PCV valve hammers against the back of this seal. And then, one day, the pressure wins. With a silent pop, the extreme pressure physically distorts the main seal, blasting a hole through the rubber lip. The entire dam breaks. The engine's lifeblood sprays out of the seal, covering the inside of the transmission bell housing and eventually pooling under your car on that beautiful Saturday morning. This is the psychological and financial catastrophe of PCV failure. The $2,000 leak. Why is this rarely mentioned in standard factory maintenance schedules, effectively ignoring it? It comes down to human psychology and marketing perception. PCV systems are mandatory for emissions, but they are viewed as boring, low-importance emission components. Replacing a PCV valve on a modern car often requires significant labor, sometimes up to 2 hours, as engineers bury it deep under intake manifolds and behind engines. By not listing the PCV valve as a regular maintenance item that requires periodic replacement, car manufacturers keep the advertised cost of ownership during the first 5 years low. They know the plastic valve will likely survive the factory warranty period. When it clogs at 70,000 miles and blows the main seal, it is not their financial problem. It is yours. Dealerships and sales brochures are designed to sell you a new car, not to ensure that car lasts for 15 years. So what is the survival protocol? How do you protect your interference engine from turning into a pile of expensive scrap metal? Here are the 3 actionable steps you must take to save your PCV system, your seals, and your wallet. Rule number 1. Establish a severe service oil change interval and ignore extended marketing recommendations. Dirty oil destroys timing chains, it destroys hydraulic tensioners, and it destroys PCV systems. This is your absolute, foundational defense against all engine component death. The contaminated oil sludge that clogs the PCV valve is the direct result of extended oil change intervals. If you want your seals to live, you must change your high-quality full synthetic oil far more frequently than the factory suggests. Experienced engineers recommend intervals closer to every 5,000 miles or every 6 months for these severe city driving conditions. Clean oil prevents sludge, and preventing sludge prevents the PCV valve from turning into a pressure cork. Rule number 2. Replace the PCV valve as a proactive maintenance item, not a diagnostic one. Do not wait for oil to pool under your car. Do not wait for a misfire. Unless your owner's manual specifically mandates a replacement interval, which is rare, you should treat the PCV valve like a spark plug or a brake pad. A typical engineering range for proactive PCV replacement is between 40,000 to 50,000 miles for modern vehicles. Spending $50 on the part and an hour of labor today is the only logical insurance policy against a devastating mechanical and financial disaster tomorrow. Rule number 3. Listen for the definitive symptoms of high crankcase pressure. Do not turn up the radio. Listen to your car. The first symptoms of high crankcase pressure are simple oil weeps. If you see engine oil suddenly weeping from the valve cover gasket or the oil pan gasket, especially on an engine that was previously dry, the pressure is already looking for an exit. Take the car to a mechanic and have the internal crankcase pressure tested with a specialized gauge. If the pressure is high, the PCV system is failing. Fixing the PCV valve immediately will often stop the gaskets from weeping and prevent the catastrophic failure of the $2,000 rear main seal. To summarize the engineering reality of modern driving. fluids degrade. Friction creates wear. Pressures must be managed. Maintenance-free is an engineering and commercial illusion designed to sell new cars. Ignored chemical sludge is the central murder weapon that kills hydraulic systems and ventilation valves. A tiny $5 plastic valve is the only official defense mechanism your engine has against destroying itself with its own internal pressure. Ignoring maintenance today guarantees you will be forced to spend a fortune tomorrow. Do not let dirty oil and commercial marketing destroy your vehicle's heart. Next time, we are diving deep inside the engine bay to look at the hidden, silent killer of modern, highly efficient engines. We will expose the high-tech lie that dealerships will never tell you about, the inevitable carbon buildup that suffocates direct injection engines, kills your power, and requires massive expenses to clean. Subscribe if you want to understand how your car really works and how to protect it from the dealership's profit-driven advice.